All right, so we're going to talk about solving linear inequalities. And so we have 4 inequalities that we're going to talk about. Less than, greater than, less than or equal to, greater than or equal to. So if you remember in the past, a lot of times we kind of show you that you're going to put a circle on the point or a solid dot on the point and then draw an arrow. Well, we're actually going to change that now. What we're going to use is interval notation. And so what we're going to look at is using parentheses or brackets. So parentheses tells me that it's not equal to. Brackets tells me it's equal to. And so now, remember, less than, I'm going to draw my arrow to the left. Greater than, or equal to, I'm going to put my arrow to the right. Okay, so we'll kind of have an example. We're going to use parentheses and brackets, and I'll try to remember to graph throughout these. And so when we're looking at this, so now we're gonna solve this. And I'm going to start talking about writing it in set notation and interval notation. So when I solve this, it'll be in set notation, and then I'm going to write it as an interval notation. So the first thing is I want to solve this. Okay, so I'm going to start with the variable with the smallest coefficient. So that's negative 2x. So I'm going to add 2x to both sides. So that gives me 5x minus 5 is less than 6. I'm going to add 5 to both sides. 5x is less than 11. So I'm going to divide by 5, and I get x is less than 11, not pi, less than 11 fifths. Okay, so this is set notation. Now, interval notation tells me I have to have an interval or 2 numbers that all the values fall into. Okay, and so I know my top number, my highest number is going to be 11 fifths. I'm going to put a parenthesis over here, okay, because it's not equal to. It has to be less than that number. So the smallest number that we could have is negative infinity. And so we would have negative infinity. Anytime I use infinity, I'm going to use a parenthesis because I can't physically get to that number. Okay? Now, if I'm graphing this, this is where this comes in nice, is now I'm going to plot 11 fifths. So it's right here. So I'm going to put a little parenthesis right there at 11 fifths. And then I'm just going to put an arrow going that direction. So this next one, I'm going to add 7x to both sides. I have 13 is greater than or equal to 7x minus 4. Add my 4 over, add my 4. 17 is greater than or equal to 17x. I'm going to divide by 17, divide by 17. And so this gives me 1 is greater than or equal to x. I'm going to flip this around so I always read it with my variable, my inequality, then my number. So this is x is less than or equal to 1. All right? So now when I come up here, I know that these values are going to be smaller than or equal to 1. So 1 is my upper bound. So it gets a bracket because it's equal to. And then I have my lower bound, which is negative infinity. It'll go all the way down to negative infinity. So now on our graph, at 1, we're going to come put a bracket, and we're going to put an arrow going to the left on that. Okay? Now we're going to find domain. So we're going to use this idea of inequalities, and we're going to find domain. So you have to understand what domain is, first of all, right? Domain is our x values that we're plugging in. You have to understand when items, we can't evaluate them. So for instance, in a square root, I can only evaluate 0 and items greater than 0. So what I'm going to do is I'm going to take the inside of this, x minus 6 is greater than or equal to 0. So I'm going to set that to be greater than or equal to 0. And now I'm going to solve. So I'm going to add 6 to both sides. And x is greater than or equal to 6. Now, if I want to write this in interval notation, the smallest value I can have is 6. It gets a bracket because it's equal. Well, how large is this going to be? Well, this is going to go all the way up to infinity, so I put an infinity with a parenthesis. Now, here's my next one. So I have a domain. I don't really care about my numerator. My numerator could be positive, it could be negative, it could be 0. The denominator has a couple of different things on it. So the square root says I can't be negative. So I have to be 0 or larger inside of the square root. But I also have the problem of, in my denominator, I can't have the 0. So this says I can, inside the square root says I can be greater than or equal to 0, but because I'm in the denominator, it says it can't be 0. So I have to set the inside 3 minus x greater than 0. Okay? And I'm going to subtract 3 from both sides. So I get negative x is greater than negative 3. Now I have a negative x here. I'm going to have to multiply it by a negative number. Hopefully you remember that when I multiply by a negative number in an inequality, so I take my negative number, I'm going to multiply it. I change the direction of the inequality. So this becomes x is less than 3. Okay, so this is set notation. I now know that the highest value I could be is 3, right? So it's a parentheses because it's not equal to. So negative infinity to 3. Okay. Last thing we're going to talk about is compound inequalities. Compound inequalities is just a big term for that's saying that you have 2 or more in one sentence. So here I have a compound inequality of negative 3 is less than 2x plus 5 is less than or equal to 7. So what I'm going to do is I'm going to take this compound inequality and I'm going to split it apart. So I'm going to go negative 3 is less than 2x plus 5. And 2x plus 5 is less than or equal to 7. So I'm going to split it apart so that way it's easier to solve. Yes, you could just solve it all in once, but the problem is that sometimes students get mixed up. They forget to subtract 5 from all of it. But you could. You could have subtracted 5 from the left, the middle, and the right, and then divided by 2 from the left, middle, and right. That's fine. So I'm going to subtract 5 from both sides here. So this gives me negative 8 is less than 2x. Divide by 2, divide by 2. Negative 4 is less than x. Over here, I'm going to subtract 5. 2x is less than or equal to 2. Divide by 2. X is less than or equal to 1. Now I'm going to bring it all back together. Negative 4 is less than x is less than or equal to 1. Now, so this is set notation. I want interval notation. So my lower bound is negative 4. It doesn't have an equal sign, so I have parentheses. I have 1 is my upper bound, and it's equal to, so I have a bracket. So this would be my where my x would fall. Okay. So here I have an or. So let's graph this one. So I want you to see that. So I have 0, 1, negative 2, negative 4. So this is going to look like this. Parenthesis there, bracket, and I'm just going to put a line between them, okay? So on our last one here, we're going to solve each of these. So I'm going to add 5 here. So 2x is less than or equal to negative 2. Divide by 2, x is less than or equal to negative 1. I'm going to solve this one over here. I'm going to add 5 to both sides. 2x is greater than 6, I'm going to divide by 2, x is greater than 3. So this is an or, right? So these are values less than or equal to 1. So let's come to our number line first here. 0, 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. I'm going to erase that one. Okay? So I'm going to graph this first, just so we can kind of look at it. So negative 1, so it's less than or equal to negative 1. So I'm going to put a bracket and go to the left. It says greater than 3. So at 3, I'm going to put a parenthesis and go to the right. Okay? Now, this is where it gets a little bit tricky, and we're not quite, there's not a lot of interval notation in there, but it's going to come in handy kind of previewing it now for later on. okay? It just asks you to graph, that's fine. But this one is going to be negative infinity to negative 1 bracket union, because it's saying and we need to take in this part also. So we're going to union 3 to infinity. I know this is kind of an extension on all of this, but it's better for you to see it now. So later on, when we really introduce it and cause everything to be written like this, you'll have seen it, and hopefully you'll be able to understand it better at that time, okay? So this is just kind of solving linear inequalities.